Today we'll be discussing city design, specifically with respect to smart cities. Let's start off with what a smart city is. A smart city uses secure networks of information and communications technology in order to manage the many facets of city life. These systems can be used to monitor and recognize patterns within the city in order to guide its development and assist with maintenance, as well as to improve the lives of its inhabitants. These systems do not always have to be rigid and static, they can also be interactive, in such a way that the people can directly influence them as well as benefit from them as a community. Algorithms are necessary and essential in handling the heavy lifting that makes smart cities work seamlessly. By collecting data and processing it, the algorithms serve not only to shape the city's infrastructure, but its efficiency as well. Several ideas for how these algorithms could be implemented to achieve this goal have been proposed. Today I'll be talking about two of them. I will now talk about a research approach to an algorithmic smart city. This study explores how an algorithmic smart city could theoretically be implemented. Kevin Lynch identifies 5 elements as being key to the way humans create mental maps of cities. Those 5 elements are paths, edges, nodes, districts, and landmarks. The study posits that these can also be used by algorithms. Such algorithms would be able to gather inputs and metrics about the city and the behavior of its inhabitants, in order to be able to produce such data as routes, destinations, travel times, and suggested places, just to name a few. The goal would to be increase the convenience and ease of living. However, many see these processes that take place in the dark, where the average citizen can never truly see. Whether this is good or bad is an open question. Some argue that while the subjects are aware of the algorithms tracking them, they change their behavior in an effort to game the system. Others argue that when such processes are in the dark, it undermines the autonomy of the people and allows hidden agents to manipulate public behavior, perhaps for their benefit. Kevin Lynch defines the 5 elements of a city as follows. Paths are channels along which citizens move. These can be identified by visual cues in the landscape or by collecting geolocation data generated by citizens. Edges are boundaries that restrict movement or require crossing. Edges can be identified through RFID access points or where network access ceases due to distance or limited power. Nodes are points of convergence for movement, such as entryways and exits. Nodes can be mobile and can emerge based on things such as changes in wireless coverage areas and policy changes. Districts are areas as citizens are defined as being either in of or out of. Districts are software-identified regions, such as a map of Manhattan according to Netflix rentals. Landmarks are useful points of reference that are visible from far away. Such algorithms could have negative impacts if the data they collect is being used by the wrong people to manipulate and incriminate others. If used by advertisers, this technology would become increasingly intrusive in our lives, constantly pestering us to buy certain things and feel certain ways. Similarly, it means that governments can much more easily manipulate and control their populace, perhaps not for the better. I now want to talk about computing brains. This study explores how learning algorithms can be applied to the smart city. These algorithms incorporate both machine learning and what is called cognitive computing. The overall idea is that certain spaces around the city would be built to learn and adapt to the inhabitants. These algorithms intend to interact with the human brain in order to augment our own abilities as humans. This study uses the example of a smart classroom, a place in which the space itself learns and adapts to the needs of the students. When applied to the smart classroom, the first useful concept is learning analytics. This process is used to track students in a class in order to provide automated predictions for future progress, recommendations of additional material, and insights for policymakers and educators. In short, the massive data collected from the students would be able to be transformed into useful intelligence to create smarter and more effective schools. The next exciting development in the quest for a smart classroom, and by extension a smart city, is what IBM calls cognitive-based learning systems. These are neuroscientific systems modeled after the brain. By having a system in place that learns similar to how humans do, the user's individual needs can be responded to in ways that are far more natural than the ways of regular hard-coded systems. This type of computing relies largely on imitating the brain's ability to rewire itself as it learns from past actions and interactions with its environment. The goal is to treat both human cognition and cognition of these computational systems as equally algorithmic, things that can be manipulated, retooled, and optimized. Just as the human cognition influences the computational environment is designed to influence human cognition. Other possible cognitive environments besides the classroom include homes, offices, cafes, and more. Eventually, a cognitive city emerges when each of these environments are networked together. It's not hard to speculate the possible negative impacts of this paradigm. Much like the algorithm in the previous case study, it's an excellent way to manipulate populations and impress certain behaviors onto people. Secondly, there are probably a great deal of unintended consequences these environments could have on the way we think. Would it be as beneficial as IBM wants us to believe, or could it possibly be a hindrance to human cognitive development? And lastly, in whose interest would these cognitive environments truly function? In the smart school, ideally the student, but what about in the office, the employee, or the boss? In a cafe, would it benefit the customer or the owner? How could those in power use this technology to reinforce their power? What is the intended goal in each space, and who decides what that goal is? These are the important questions to consider.